Hello and welcome everyone. Today we're going to see how we can control our families more professionally through defining conditions. Let's begin our work with an example. Well, actually, to be more precise, with answering a question. Let's say we got a family and we want to be able to control its endpoints parametrically, talking about its length, its width, and so on. Now, the question here is how we can do that. Well, let's find out together. Right, so for answering this question, there are some steps that we need to take. First step is to enter a new family template, more precisely, a line-based family template. So in this step, from the list of the family templates that I got here, I'm going to go with generic model line-based. Now I'm going to try loading this profile, which actually has many names, an monolith, polystyrene, styrofoam. Let's just call this an EPS, actually. Anyway, I'm going to load this into family 1. And then I'm going to try setting it somewhere around here, like this. All right, I'm going to expand this a bit. Now, let me check whether we're dealing with a parametric profile or not. The length is 1 meter and it's parametric. Yeah, so we can easily change this. Now, one idea that I have for this would be reproducing it. Now, surely you already know how to reproduce the elements. You can use copy, you can use array. I'm using array, for example, here. Yeah, give me like maybe like 4 or 5 of them. By the way, guys, I'm kind of cooking this while I'm going on. Like, I'm trying to show some creativity. So if you want to, you can actually think of different ways. Right, I'm creating this parameter here called number. Good. Now, the total length that I have in mind for this, guys, would be about like maybe 8.5 meters. Now, for the number, guys, the number parameter, we have 5, but I want this to be calculated a bit more parametrically. So what I'm going to do here would be specifying or defining a formula. What I have in mind would be length divided by 1,000. So let me just go ahead and type this down in the formula segment. And by the way, guys, we should make sure that we're not misspelling anything. Now, as a result of this defined formula, guys, the number parameter would be set on 8. And I guess we can enhance this a bit more, so I might think of some better ways later on. For now, what should we do for this last bit, guys? The idea that I have for this part, guys, begins with using a reference plane. Now, one more time, guys, remember what we're doing here would kind of be brainstorming. So, again, if you can and if you like, think of other ways, think of different ways. Now, I kind of have another formula in mind, guys, for this length here. Let's say this number times 1. So let's test this out. Let's see whether this formula works for us or not. I need to work on the parameter first. Let's say this is an instance parameter, a reporting one actually. Yeah, I mean, let's say, for example, we want to get some information out of this parameter. Or, we can even go with an instance one, not even reporting. Let's call this end. Something for controlling the endpoints of our panels. Okay, now that we have this new parameter, let's give this a formula. The formula that I have in mind would be number times 1,000. Okay, now let's test these. I'm going to go ahead and set the length here on, let's say, 730. As you can see, other parameters would act accordingly. Now, next up, I'm going to try setting a single profile here, guys, a single family ESP, whatever this was, here. And then I'm going to try aligning this or attach this, connect this, basically, to what I have up here. Now remember guys, the end of array was here up to this profile and we added this single one. Now I'm going to select this and try getting a duplicate. Let's call this JUS, as in justify. And then for the L parameter here, I'm going to go with 400. Does it work? Okay, maybe less though, like instead of 400, give me 300. Now, what if I were to give this an associated parameter, guys? You know what? Let's test this. So I'm going to create this parameter here, this instance parameter. An instance parameter that I'm going to call LJust, as in the justifies length. All right, now we got this parameter in our family and type tab. Next up, I'm going to go ahead and try giving this a formula as well. And the formula that I have in mind for this would be length minus or subtracted by end. Now, I honestly don't know whether this works or not, so let's test this together. What I'm going to do here would be setting the length on maybe 10,350. You know, seems fine. I mean, it kind of works quite nicely, yet I guess we still have a couple of problems. I'm going to go ahead and set the length here on 11,100. Let's see what we're going to get. Okay, so we'll be getting something like this. How about 11,000? All right, here we go. We'll get a warning, as you can see, guys, an error like this. Yeah, this constraint does not really work here, guys. So yeah, this will be one problem, and we'll be discussing another shortly. So we can kind of say that the first problem here was dealing with this length when it is set on a roundup value. Now, let's try discussing the other problem, the other issue, guys. For doing that, I'm going to go ahead and set the length here, this time on, let's say, 96,000. Sorry, I mean 9,600. Now, when we do this, guys, we'll be getting another error. As you can see, the number would be set on 10, and the end parameter would also be increased. In other words, guys, we would kind of be getting an extra panel here. So yeah, and this is another problem, another issue, another error that we can't simply ignore. We should think about it. We should do something about it. So basically, guys, up to this point, what we did was kind of proposing more questions, or you can say raising more questions, more issues, and we need solutions. And we're going to talk about them shortly. But before doing that, I'm actually going to show you some slides. Before we begin, guys, if we set the length here on 9600, we'll be having a problem. But if we go with 9650, for example, it works. By the way, guys, if you were to work on these in another software such as Excel, in that we actually would have had access to some, well, functions and configurations, but unfortunately we don't have them here. Anyway, guys, as I said, let's go through some slides together, and after we're done with them, we'll be circling back to these problems again. Right, so let's talk about conditional formulas, guys. Basically, the main structure would be like this: if, then the condition, and after that, the possible results based on the validity or invalidity of the condition. As an example, take a look at this, guys. Here we have if x was less than 10, give us x itself. Otherwise, and by otherwise, I mean if it was greater than 10, the result should be, for example, 12. So, for example, if we use a value like 5 here for x, the result would be x itself, because 5 is less than 10, so we'll be getting 5. And then if we use a value like 100 here, because 100 is greater than 10, the result would be 12. And yeah, that would basically be it, guys. That would be the main structure that we can use for creating a condition or a conditional formula. Now, let me show you something else, guys. Take a look at this formula that we have here for trim width. The formula goes like this, guys. If trim, 70 millimeters, 0 millimeters. Now, what does this whole thing mean, though? You can say that such a formula goes for items with a parametric visibility parameter, kind of like what we're going to work with right now. In this case, if trim actually means that if the visibility parameter was enabled for trim, the trim width should be 70 millimeters, and otherwise, in other words, if it wasn't enabled, give us 0 millimeters. So this is basically a very simple yet important point here, guys. You can say that this is some sort of a short and concise kind of formula. Now let's take a look at another one, guys, another type of equation, you can say, which contains an AND factor. As you can see here, we have if and A, B. This means that if both A and B were enabled, C should be 1, otherwise give us 0. Now, as another example, if item 1 was enabled, give us 4. And interestingly enough, we have a new condition if it was otherwise. In other words, we have another if factor. Like if in case 2 was enabled, give us 6. And again, otherwise, another result if 3 was enabled. So basically, guys, the point towards which I'm trying to point is the fact that this is how to use several if factors within a single formula. Okay, guys, now back to Revit again. In order to define a formula here, to use a formula here, we need to say something about this bit, more precisely about the last panel's length. Now, if you recall, guys, a few minutes ago, I mentioned that we need to be working with a visibility parameter here. So I'm going to create another parameter here, a parameter that I'll be calling justify visibility. Okay. Now I'm going to load this newly created instance parameter into my project. Next up, guys, if you take a look at the Properties tab, we would see a parameter called Visible. We need an associated parameter for this. Well, this is actually quite obvious, so I'll be creating another instance parameter for this. And after doing so, we'd be able to open up Family and Type and start using the parameter. Now, take a look at this, guys. Currently, this parameter is enabled, which is fine, which is cool. However, in case the length parameter subtracted by end was equal to 0, this justify visibility parameter should be disabled. So, as a result, guys, the formula that I have in mind for this whole bit would be something like this. We don't need an if here, by the way. I'm going to go with length subtracted by end equal to 0 millimeters. See, the whole parameter got disabled. Now, we need an inverted version of this as well, guys. So, I'm going to go ahead and add not before everything here. So we can kind of say that, guys, by adding this whole not factor to our equation, we kind of just somehow, you can say, control the existence of our parameter. Or you can say it's functionality. All right, so once again, we got another formula here. And as always, we need to go ahead and test it out. So I'm going to go ahead and set the length here on, let's say 9,000. Let's see. So the parameter got disabled, but we would also be getting this remove constraint error again. So what should we do about this one then? Any ideas? Well, I've got some ideas. Well, as for one thing, guys, I do not really care about the length here, to be honest. I mean, the only important thing about it is the fact that it shouldn't be 0. That's it. For example, it could be like 1 millimeter, for all I care. So, having said what I just said, guys, I'm actually going to go ahead and work on another formula. I'm going to define another formula, which goes like this. If, open parentheses, length subtracted by end was equal to 0, give us something like, as I said, it's not really that important here. So, for example, give us like 100. Yeah. All right. And otherwise, I mean, if length minus end was not 0, give us the exact value or the exact amount. I mean, length minus 0 itself. Yeah, I think this one will do, guys. Let me close down the parentheses. Yeah, I guess it worked. But we still need to go back to our viewport and check this further, guys. Okay, so I guess this part here is extra. Oh, more precisely, guys, it actually seems that way because preview visibility is off, I guess. Yeah, let me turn it on. And guys, I honestly believe that we actually did it. Like, we solved the problem with a little bit of creativity and formula. Give me 9300. The panel should be added now. Yeah, it did actually. How about 10,000? Oh, in this case, the panel should become invisible, which is exactly the case. Now, let's test this within our project, guys, and then we can talk about another issue. As you can see, guys, while I'm trying to use this profile, set this profile, it seems like the formula is working, but we still have another issue that we actually need to talk about. All right, so let's go ahead and talk about it, guys, right now, actually. The other issue was something like this. If I go ahead and set the length here on 3600, as a result, we'll be getting an extra panel. Now, someone actually suggested that we would set this on number, guys, since we don't have any control on this number parameter here, because we are kind of considering the array number here, right? Anyway, guys, try answering me this. How can we find out that this is surpassing or passing half? Well, for answering this question, guys, take a look at the first value that we're getting. We're getting 1500. So then, if I go ahead and set the length here on 1500, the number would automatically be set on 2. But if I go with 1499, we'll be getting 1. Now, how about 2000? Well, again 2. How about 2500? And actually, guys, we have an issue with such values like 2500, 3500, and values like these, basically. Now, to put this simply, guys, we need to be adding a -1 to this whole equation here, and we need to be doing a bit of analysis to find out when exactly we should be adding this value. I mean, an analysis regarding the length. Honestly, guys, we can kind of claim that we're dealing with a mathematical problem rather than a Revit problem. Now, before moving on, let me just check my formula real quick. Okay. All right then, guys, take a look at this. As you can see, 9100 is giving me 9. And the result of 9600 would be 10. Now guys, what I have in mind for this would be dividing the length by 1000. And then also, as for the type, I'm actually going with number. I mean, as you can see here, I've added n. And as a result of all of this, and well, as you can see, actually, I'm getting 9.6. And also, if the type here was integer, I'll be getting 10, as you can see. Now, what was the previous value that we had for the length? I guess it was 9100, if I'm not mistaken. Yeah. So, take a look at this. I'm going to go with a 9100 again. And as for the number, I'm getting 9.1. And for the integer, 9. So, what I'm trying to say here, guys, is that for the length, if we go with a value less than 9500, this will be rounded up, kind of downwards, you can say. For example, exactly like what we just saw, 9100 would be rounded up to 9. But if we go with a value greater than 9500, like 9600, this will be rounded up upwards, as you can see, 10. And yeah, that would be the underlying logic. So let's try 9400. The integer would be 9, exactly. How about 9600? 10. Great. Now, what was our issue again? Well, when we were dealing with values greater than 9500, I mean, in that case, we would have gotten an extra panel, right? Now, what I did was creating another parameter here called the delta. You know what, let me just show you this again. Give me this parameter. And as for its type, I'm going with number, not integer, number. And I'm somehow using this parameter to find the difference. I mean, if this value was less than half, like 9400, the delta should be a minus value. I mean, because the integer would be rounded up downwards, like less than the real number. And well, I basically do not have any problem with this. But if this number was greater than half, this whole situation would be inverted and the delta would become a positive number. Now, as a result of this, I can go ahead and reduce the number of my ESPs or families by 1. So again, we need to reduce this by 1 when the delta was a positive number or when this value was above 9500. Now, obviously, I need another formula here, which goes like this. Length divided by 1000. And then, if delta, the delta parameter, was greater than 0, in other words, if it was a positive number, give me 1. I mean, that whole reducing by 1 situation. But if the delta was less than 0, I mean, if it was a minus number, or if the value of the length was less than 9500, the value would be correct. So just reduce this by 0. Now, this will be one technique for defining such a formula. There's also another one in which we don't really, we're not going to use this whole delta parameter. Now, the other technique or the other formula goes like this. If the integer n was greater than, oh, what's happening here? Sorry, I didn't look at my viewport. Let me do this again. Let me try this again. So if the integer n was greater than n, the number, basically. Okay, it actually didn't work, and I thought so, because we're using two different units here, one integer, one number. Now, guys, in case something like this happened, add divided by 1 to the whole equation. Usually it works. And more precisely, guys, we need to add this to the number part. I mean, we would have number divided by 1 here. And usually, and most of the times, this would solve everything. Let me see. If I go with 9300, I'm getting 9. How about 98? Again, 9. Now, I can actually remove this. And also, by the way, guys, remember, all of these parameters should be defined. Now, let's go back to our project and test this whole thing. Let's try using this profile again, this family. Well, as you can see, it works quite nicely. No problem. Yeah, I honestly don't think we have any other issue with this family. And this is a very good one. Awesome.